Build cross-platform Python GUI apps with Kivy. Python is well known for having a wide range of functionality built in with its batteries included philosophy. While it has a graphical user interface, GUI toolkit built in the shape of Tkinter, it's a library which appears different on different platforms, and it doesn't offer the possibility of cross-platform mobile support. Kivy is a GUI framework which is truly cross-platform, offering a consistent user experience across Windows, macOS, and Linux. In this course, you'll see how to make use of the Kivy framework and Python to create GUI applications that you can package across multiple operating systems. You'll learn how to work with Kivy widgets, lay out the UI, add events, use the KV language, create a calculator application, package your application for Windows, Linux, and macOS, and take a look at what's needed for packaging for iOS and Android. This course assumes you're familiar with object-oriented programming, but if you're not, then Real Python has you covered with this Object-Oriented Programming in Python 3 course. So now you know what's going to be covered, let's get started. Understanding and installing Kivy. Kivy was first released in early 2011. This cross-platform Python framework can be deployed to Windows, Mac, and Linux. It supports multi-touch events in addition to regular keyboard and mouse inputs. Kivy even supports GPU acceleration of its graphics since they're built using OpenGL ES2. The project uses the MIT license, so you can use it for free and commercial software. When you create an application with Kivy, you're creating a natural user interface or NUI. The idea behind this is that the user can easily learn how to use your software with little to no instruction. Kivy does not attempt to use native controls or widgets. All of its widgets are custom drawn. This means that Kivy applications will look the same across all platforms. However, it also means that your app's look and feel will differ from your user's native applications. This can be a benefit or a drawback depending on your audience. This course was created using Python 3.10 and Kivy 2.10. Kivy has many dependencies, so it's recommended that you install it into a Python virtual environment. If you've never used a Python virtual environment before, then check out Python Virtual Environments, a primer, to get you up to speed. Here's how you can create a Python virtual environment. This will copy your Python 3 executable into a folder named venv and add a few other subfolders to that directory. To use the virtual environment, you need to activate it. On macOS and Linux, you can do that by executing the command seen on screen. The command for Windows is similar, but the location of the activate script is inside of the scripts folder instead of bin. Now that you have an activated virtual environment, you can use pip to install Kivy. If you run into any issues installing Kivy on your platform, then see the Kivy download page for additional instructions. In the next section of the course, you'll get started with using Kivy. Working with Kivy widgets. A widget is an on-screen control that the user will interact with. All graphical user interface toolkits come with a set of widgets. Some common widgets that you may have used include buttons, combo boxes, and tabs. Kivy has many widgets built into its framework, and in this part of the course, you'll look at using a couple of them, starting out with Label. To see how Kivy works, let's take a look at the code of a Hello World application. Every Kivy application needs to subclass the app class and override build. This is where you'll put your UI code or make calls to other functions that you define. In this case, you create a label widget and pass in its text. To make the application run, you instantiate your main app class and then call run. Save the file, open a terminal and run the script as seen on screen. You should see the Kivy application. You'll also notice that Kivy outputs a lot of text to the terminal, and this is useful for debugging your application. The label class has many properties that can be specified, but as a quick demonstration, let's just change the font size from the default to much larger. When running the app now, you'll see the increased text size in the window. Next, you'll try adding an image widget and see how that differs from a label. Kivy has a couple of different image-related widgets to choose from. You can use image to load local images from your hard drive, or async image to load an image from a URL. For this example, you'll stick with the standard image class. The image class takes a lot of different parameters, but the one that you want to use is source. This tells Kivy which image to load. Here you pass a relative path to the image. The rest of the code is the same as in the previous example. When you run this code, you should see something similar to what's seen on screen. The text from the previous example has been replaced with an image. Now that you have the basics down, in the next section of the course, you'll learn how to add and arrange multiple widgets in your application. Laying out the UI. Each GUI framework that you use has its own method of arranging widgets. For example, in WX Python, you would use sizers, whereas in Tkinter, you use a layout or geometry manager. With Kivy, you use layouts. There are several different types of layouts that you can use. The most common ones are box layout, float layout, and grid layout. Kivy's documentation will give you a full list of available layouts. Here you'll try out box layout with the code that's seen on screen. First, you import box layout from Kivy UIX box layout. Next, you create some colors which are lists of R, G, B, and alpha values. These are then added to another list, colors, which becomes a list of lists, allowing easy random selection of these pre-selected colors. You create an instance of box layout and loop over a range of 5, creating a button BTN for each iteration, with the background color of the button set to a random color. You then add the button to the layout. After the loop has ended and 5 buttons have been added to the box layout, the layout is returned. When you run this code, you'll see something similar to what's seen on screen, although your colors will be a random choice. When you create a layout, there are a few arguments you should know. Padding. You can specify the padding in pixels between the layout and its children in one of 3 ways. A 4-argument list, padding left, top, right, and bottom. A 2-argument list, padding horizontal and padding vertical. or a single argument of padding. Spacing allows you to add space between the child widgets, and orientation allows you to change the default orientation of the box layout from horizontal to vertical. Like most GUI toolkits, Kivy is mostly event-based. The framework responds to user key presses, mouse events, and touch events. Kivy has the concept of a clock that you can use to schedule function calls for some time in the future. Kivy also has the concept of properties, which works with the event dispatcher. Properties help you to do validation checking. They also let you fire events whenever a widget changes its size or position. Let's add a button event to the previous example. First, an index attribute is added to the button object. This will be used by the function that you'll add later. Next, you call buttonBind, and this links the onPress event to the main app onPressButton method, which you're going to code in a second. The method implicitly takes the widget instance, which in this case is the button. Finally, the onPressButton method is created. This prints out a message to the terminal indicating which button has been pressed by making use of the index attribute that was added earlier on. When you run the program, you'll see something similar to what's seen on screen. In the next part of the course, you'll take a look at using the Kivy language to create your layouts. Using the Kivy language. Kivy also provides a design language called Kivy that you can use with your Kivy applications. The Kivy language lets you separate your interface design from the application's logic. This follows the separation of concerns principle and is part of the Model View Controller architectural pattern. On screen, you'll see a simple example which will make use of the Kivy language. This code might look a bit odd at first glance as it creates a button without setting any of its attributes or binding it to any events. What's happening here is that Kivy will automatically look for a file that has the same name as the class in lowercase without the app part of the class name. In this case, the class name is buttonapp, so Kivy will look for a file named button.kv. If that file exists and is properly formatted, then Kivy will use it to load up the user interface. Go ahead and create the file and add the code seen on screen. This matches the button call in your Python code. It tells Kivy to look into the instantiated object for a button definition. This sets the button text, and here you set the width and height with size hint. Size hint tells Kivy the proportions to use when creating the widget. It takes two numbers. The first number is the X size hint and refers to the width of the control. The second number is the Y size hint and refers to the height of the control. Both of these numbers can be anywhere between 0 and 1. The default value for both hints is 1. Next, you set the button's position with pos hint. Here you tell Kivy to center the widget on the X and Y axes with a value of 0.5 for each. This line sets the onPress event handler. To tell Kivy where the event handler is, you use app onPressButton. Here, Kivy will look in the application class for a method called onPressButton. With both files saved, running the Kivy example script works as expected, with Kivy pulling the information from button.kv behind the scenes and creating the layout as expected, with onPressButton working as desired. You can set up all your widgets and layouts inside one or more Kivy language files. The Kivy language also supports importing Python modules in Kivy, creating dynamic classes, and much more. For full details, check out Kivy's Guide to the Kivy language. Now you're ready to create a real application, and that's what you'll be doing in the next section of the course. Creating a Kivy application. One of the best ways to learn a new skill is by creating something useful. With that in mind, you'll use Kivy to build a calculator that supports the following operations: addition, subtraction, multiplication, and division. For this application, you'll need a series of buttons in a layout. You'll also need a box along the top of your app to display the equations and their results. On screen, you can see a sketch of the calculator. Now that you have a goal for the UI, you can go ahead and write the code. First, you create a list of operators and a couple of handy values, last was operator and last button, that you'll be using later on. Next, you create a top-level layout, main layout, and add a read-only text input widget to it. Here, you create a nested list of lists containing most of your buttons for the calculator. In this line, you start a for loop over those buttons. For each nested list, you'll do the following. Create a box layout with horizontal orientation. Start another for loop over the items in the nested list. Create the buttons for the row. Bind them to an event handler. And add the buttons to the horizontal box layout that was just created. Finally, you add this layout to main layout. As a last part of the layout, you create the equals button. Bind it to an event handler. And add it to main layout. As you've already seen, most of the widgets in the application call on button press, so that's what you'll be coding next. The method definition takes the instance argument so you can access which widget called the function. The values of the solution and the button text are extracted to variables. Here, you check to see which button was pressed. If the user pressed C, then you'll clear the solution. If they pressed any other key, then the program moves on to the else statement. This checks if the solution has any pre-existing value, and here you check if the last button that was pressed was an operator button. If it was, then solution won't be updated. This is to prevent the user from having two operators in a row. For instance, 1 times divide is not a valid statement. Here, you check to see if the first character is an operator. If it is, then solution won't be updated, since the first value can't be an operator value. If none of the previous conditions are met, then solution is updated with the new text. Last button is set to the label of the last button pressed. And last was operator is set to true or false depending on whether or not it was an operator character. The last piece of code to write is on solution. Here you get the current text from solution and use Python's built-in eval to execute it. If the user created a formula such as 1 plus 2, then eval will run the code and return the result. Finally, you set the result as a new value for the solution widget. Note that eval is somewhat dangerous because it can run arbitrary code. Most developers avoid using it because of that fact. However, since you're only allowing integers, operators, and the period as input to eval, it should be safe to use in this context. The last piece of code needed for the application will already be familiar to you, creating the app from the class that you've written, and then invoking the run method. When you run the code on a desktop computer, your application should look as seen on screen. Now that you have a complete application, it's time to package it for deployment, and that's what you'll be looking at in the next section of the course.